a good recording window. Let me fix this. No, all right, so we're on worksheet 13. We're going to be writing equations of parabolas today, and then we're going to do what I call throw-up problems, which are applications, largely ones about, you know, the ball went up and it came back down, and so it had a quadratic rate so that it, due to gravity, the acceleration due to gravity makes it look like it's a parabola. It's not really, but all right. Warm up. Can anybody remember any of the forms of parabola from last week? Anybody quote me vertex form or even standard form? Standard form is easy. Ax squared plus bx plus c, okay? There's also like intercept form or something it was called. I think it's still A. We'll call that B and C. I don't know. It's not B and C though. I don't know what it called it. Does anybody have their notes? Just called it factored form, but what did it call it? An x minus. Okay. Okay. And did it have A? Is it still called A out there? Okay. Thank you. Obviously not super comfortable. Don't use that one very much. I just didn't want to confuse you by using the same letters we used over here. Then the one that's big today is vertex form. All right. The A is the same, but then it goes x minus h squared plus k. Okay. Can you make sure you put that at the top of your notes? Vertex form we're going to need today. Okay. Vertex form, y equals a, which is the stretch, or it also tells us whether it's opening up or down, x minus h, where the opposite of that, h, is the x value of the vertex, and then k is the y value of the vertex. So the vertex is at hk. All right, now we're going to talk about converting this mess to vertex form. We're going to kind of do this the cheater way. You're supposed to like complete this square and do all this funky stuff, dividing through by -2. I'm just going to have us find the vertex. Because if we can find the vertex, then we can put a x minus h squared plus k, and we'll be done. We already know a. Guys, what's a? Yep, a is -2 right there. So we're going to have a -2 when we're done for the a value. But then we need h and k. Does anybody remember the vertex finder recipe? Yes, -b over 2a. And this can say h or x. It's the x value of the vertex, or it's the axis of symmetry. So we need -b over 2a from right up here. The opposite of our b, anybody? 12, everybody good? That we have a, b, c here. This is -12, so the opposite is 12. All right. And then it's over 2 times a, which would be 2 times -2. We have to do that first, so we get 12 over -4, which is -3. So this is going to be minus -3 right there. But then how do we find the other part of the vertex? Does anybody remember? Yeah, we got to plug this guy back in, up into the equation. So we're going to have -2 times -3 squared minus 12 times -3 minus 5. Wow, that's a lot of minuses and negatives. Can you do that on your calculator and get it right? We had a -2, and then in parentheses, I already forgot, was it -3? negative 3 squared. And then I forgot again. Was it? Why can't I move this? Minus 12 times negative 3 minus 5. Minus 12 times negative 3 minus 5. Did I get them all in there right? Anybody get 13? No? Let me go back and do it. This should be positive 9 times negative 2 is negative 18. This should become a plus 36, which is 18 minus 5 is, I got 13. Did someone else get 13 on their calculator? Okay. So positive 13 is the K value. One more time. How did we do that? We plucked the A out of there, right? And then we found the vertex. This was H and this was K. And we just plugged them into vertex form. That's a question on the quiz this week. Change to vertex form. All right. These were the standards that we talked about last week. I can graph a parabola in vertex form. I can find the vertex of a parabola when it's in standard form. That's what we just did, negative b over 2a. I can convert an equation from standard to vertex. That's what we just did, the whole question. I can find x-intercepts, y-intercept, and vertex using technology. Max, what were the x-intercepts called? Anybody remember? Zeros, yes. The y-intercept, how did we find that? Yeah, we plugged in x equals 0, like trace or value. And the vertex was either the max or min. Okay, we're going to need all that today. Now, this is actually a little bit changed from what you have on the front of the cover sheet for learning targets. I got rid of the hardest kind, which are called maximizing and minimizing optimization problems. We're just going to do applications primarily today that deal with the height of an object. Okay? But the rest of this, finding zeros and finding, writing the equation is kind of new, this one. But the rest of this is just using your calculator. All right. So it says find the equation of the parabola for each graph or set of information below. Start with vertex form, then find the stretch A by putting in another point and solving for A. So all we're going to do is we're going to have vertex form. We're going to be given the vertex or able to find the vertex from the picture. Can anybody tell me the vertex of this? Assuming the scale is 1, 3, 2. Does that sound right to everybody? So what do you know about 3 and 2 if that's the vertex? 3 is H and 2 is K. Because it's a vertex. Everybody good? H and K. So we're almost done already. We could write y equals x minus 3 quantity squared plus 2. We just put in H and K. Then we have to figure out if there's a stretch. And I'm going to tell you on the quiz, I made the stretches kind of ugly because I want you to have to find them in this way so you can't just guess. By ugly, I mean they're like fractions, a lot of them. But what you have to do to find that stretch or A value is plug in one of these other points. So if we use this guy right here, that looks like 2, 1. We're going to plug that value in for an X and a Y. If we plug all of that in up here, okay, we should be able to find A because A will be the only thing remaining. All right, let's try it. So the vertex was at 3, 2. We have an extra point of 2, 1, which is an X and a Y. This is an H and a K. All right, so what is our Y value we're going to plug in? 1 equals, A is what we're trying to find. What's x? 2 minus h, which is 3, squared plus k, which is 2. Now, students do this next step wrong all the time because they think they can do all of this at once. Can I just type all of this in my calculator? No, because this is what's multiplied by a, right? How am I going to get rid of that plus 2? I'm going to subtract it over here. So that gives me a negative 1. And then I have a is multiplied by this. 2 minus 3 is negative 1, but when you square it, you get what? Positive 1. So if I divide by 1, all I get is a is negative 1. Does that make sense for our graph? It's opening down, right? It's opening down. Does that negative make sense? All right, let's try number 2, or why don't you try number 2? Can you figure out the ordered pair for h and k? And for one of these x, y? And you can use either x, y, guys, either extra point. You just can't use the vertex as your x, y because there's no stretch there. It won't help you find the stretch. Let's see. Oh, I don't know if I can count that. Does it look like negative 5, guys? Okay. And then 2, 1. So vertex form, and some of you might just need to keep writing that down until it sinks in, is going to have an A and then X. What's going to go in the parenthesis? Anybody tell me that? X minus negative 1 would be plus 1, and plus K on the back will be, yeah, negative 5. Okay, so plug in your X, Y, H, and K and solve for A. Can you try that? Let's see, Y is 1. X is 2. Minus H would be minus negative 1. Plus K, which is negative 5. What do we need to do first to solve that? I got it that it's negative 5, so we need to add 5. You're good, you're good. That's a 6, and then all of this is multiplied. But what is 2 minus negative 1 quantity squared? Be careful. That's 3 squared, which is not 6, right? It's 9. Use your calculator if you need to, because I was making answer keys for Friday's quiz, and I was like, oh, 3 squared is 6. No, that's not going to work out so well. All right, then make sure you divide correctly. We're dividing by 9 to get A. A is 6/9, which reduces to 2/3. How about we take a commercial break to prove to ourselves this is right? Everybody okay? All right, so I'm going to go to the calculator and go to my y equals, and I'm going to put in what we just got. And I don't think you need these parentheses, but I always put fractions in parentheses. 2/3 times the quantity x. Can anybody remind me what we just did? Was it plus 1 or 3? 5? Plus 1 squared. Was that minus 5 on the back? Yay, I remembered something. Okay, now how could we check? Well, we could graph in a standard window, so we could do zoom 6. Is it a standard window that we're shown? Probably not, but can we tell a little bit that it's looking right? But we could also look at the table, second graph, And we could see that it does go through 1, -5 and 2, 1. I don't remember. Were those the points we used? Okay. So there's a way to check that we got it right. All right. There's a couple more. Do you want to do D or E? I don't think we need to do both. Anybody care? D? All right. I don't know what happened to C. I realized when I was looking at this worksheet today that, okay, what are we going to label these 2 points if this is the vertex? H and K. And then these are just some random point that it goes through, so we're going to call them an X and a Y. And then I'm going to go with vertex form. And I'm going to put all those in. Let's see, the Y was 7. The X was 0. Minus -1 will be 1. Plus K is 4. After we square that, whole mess is just 1, isn't it? So we get 3. What should that parabola look like if we graph it? Anybody know what an A value of 3 would do? It says it's at -1, 4. Crosses at 7. It's going to open up, and the A value greater than 1 should make it very narrow. Okay, skinny. Now, what's my answer then? Y equals 3. X minus -1 or plus 1 squared plus the K of 4. So vertex form answer means that we have an X and a Y in the equation, but everything else is replaced. Feel like you got it? There's one more there to practice if you need to do it. We could come back at the end if somebody felt like they needed a little more practice. All right, number 2 starts the application section. This says, from the top of a building, a toy rocket is shot upward with an initial velocity of 132 feet per second. Okay, if I gave you an equation, which we will learn later, that would be initial velocity, or V sub 0, but it's already plugged in for us today. The formula gives the height of the rocket above the ground at time t. So remember, t equals time. Assume that t equals 0 is when the rocket left its launch pad. H is height in feet, and this is the equation we're going to use. It says to use H equals -16 t squared, but we're going to put it in our calculator as an x, because the only way to get a t and use it correctly in your calculator is do parametric mode, and we're not doing that. Bella, are you doing the notes with us? Okay, x squared plus 132x plus 60. So we're going to graph this in our calculator to find this stuff really easily. So we're going to go to y equals, and make sure you use the negative, not the minus, 16, and we're going to use x squared plus, I already forgot, 132x plus 60. Okay, now, this is an application problem, so our standard window is not going to be very helpful. Okay, this is, if you put in x equals 0, what is the y-intercept here? Can you do that in your head? You make that 0, all that's left is 60. So it goes up high, it starts up high, okay? And then it's going higher. So I'm going to go to window. What did the X stand for? I need you to be able to figure out, and this is tricky, a window that makes sense for the situation. X was time. Do we have such a thing as negative time? No. So I'm going to say to give me X values between, let's say, 0 and 10 to start. Most things will fall to the ground before 10 seconds are up, right? All right, the height, it doesn't matter so much if you want to leave that -10, or you could make it 0 because you can't really have under the ground. But if you leave it -10, sometimes it helps you see where the ground is. But we said it goes up to 60 before it ever starts going up. So I'm going to try, I don't know, 400 maybe? I'm just picking a number, okay? Then I'm going to go to graph. Ooh. That was a really nice window, and that was totally a guess. Now, would it work if your window was bigger so that your little parabola was looking smaller down in the corner? Yes, it would work. Okay. This is a nice window because it fills most of the screen. But if the top of your parabola is cut off, then you don't have enough what yet? What's at the top? X or Y? Y, and min or max? Max. So if you do not see the top, you would have to change the X max. If it's not coming down over here, you would need more X. Did I just say X? This was Y max up here. Top was Y max. X would be if you need to go to the right further. I'm so helpful. Are we good? Okay. Let's go to the questions. How tall is the building? How do we know that? Yes, it said from the top of a building, and times 0 is when it left the building, right? Left the launch pad. So if we put in a 0, we came out with a 60. So the building is 60, and it said height in feet. So we have 60 feet. So we could have done, to our graph, we could have done trace 0, enter, and we should have gotten 60. It is the y-intercept. Next question. How high above the ground was the rocket at 3 seconds? How can we figure that out? Yep, we could put in x equals 3, or we could use the table. So on your graph, you could do either one. You could go 3, enter, once you're done trace. So trace 3, enter, and I get 312. Or I could look at the table, and it says at 3, it's at 312 feet. Any questions about that? These are questions you have to do for the quiz. This is how easy of applications I picked, okay? At what time did the rocket hit the ground? What are we trying to find there? Yes, we're trying to find how long it took to get here. How long in time is x? So we're trying to find the x value over here. And what did we say we're going to call that? The 0. Yes. Now, so we would actually put in y equals 0. If we were doing this by hand without a calculator, we'd probably have to use quadratic formula with -16, 132, and 60. That doesn't sound very fun to me. Okay? But we're going to find it on the calculator using the 0. Now, do you remember how to use the 0? We practiced this a little bit last week, but it's second trace, choice 2, and then you need to be to the left and right of this. If I count 1, 2, 3, 4, 5, 6, 7, 8, it looks like it's between 8 and 9 seconds to me. So I'm going to type, if you want to scroll around, you're welcome to. I'm going to say it's between 8, and I could even say 10. It doesn't matter what, as long as it's in between those. And then we're going to go to the nearest hundredth, because I believe that's what I put in the quiz. So 8.68, did someone else get that? Is anybody not getting that? Okay, I hope you're doing this on a calculator so that you're practicing these buttons. We got x equals 8.68 seconds. Now, did anybody get a wonky number for y? Like something with an E? Yeah, I do that all the time. It gives me wonky answers back here. It is 0. It's just in scientific notation. Do you know what I'm talking about, guys? The E means times 10 to the, and It'll be like E negative 14, which is going to be a decimal point, 13 zeros, and then some number. Well, that's basically 0. All right. We have, at what time did it reach its maximum height, and what is the maximum height? If we had to do that by hand, we would do x equals negative b over 2a, and then we plug it back in from there to here. But what are we going to do using the calculator? Yeah, we're just going to find the max. And then one of those spots gets the x value and one gets the y value. Let's find the max. So it's second trace. Number 4 for maximum. I don't have, it's in this window, so it's got to be between 0 and 10, right? If you want to scroll around, you have to be to the left of it. The calculator will find a maximum anywhere because it just tries values, and when it finds the biggest one, it's done. So you need to be very clear that you're to the left and right, and you want the maximum in between those. Did anyone else get this? Okay. So which answer is it looking for the first blank? The y, because it wants the height first. Is that what it asks first? This would be the height, and this would be the what? Time. Okay. So, I got D as what time? Yes? So D is actually 4.12 seconds, and then E is the height, which is was it 312? Okay. And that was feet. Thank you. Okay, this is the weird one, and I don't think I put this on the quiz this time. At what time was the rocket exactly 300 feet above the ground? You could look at the table, and it might hit exactly 300. I'm guessing not so much. Does anybody know, does anybody remember another way to find that? If we were doing this by hand, we would have to plug 300 in and then solve, subtract it over, and then use quadratic formula all over again. Okay, guys, this is a new one for some of you. I want you to go back to y equals, and we are trying to find where it hits 300. So can you put just 300 in another one of your blanks here? And then graph it. Now, it hits 300 twice, right? How do we find those now? Does anybody remember? Yes, it's the intersection point now. All right, so we went to y equals, we put in a line at 300. Is that right? Did it say 300? Okay, for a moment I'm doubting myself. Then we're going to go to intersect, which is choice 5. So second trace, choice 5. Now the thing about intersection is it asks which two things, if you had a whole bunch of equations in here, you'd have to pick the right two, but we only have 2 in there, at least I do. So I can hit enter, I mean the parabola, and the second, it says curve, but it's really a line. I hit enter for that one. And then you have to kind of do a guess because it's going to find the closest one. So make sure you hit enter until it says intersection. I got 5.54. Did anybody else get that one? Okay. And then I need this guy over here. So I'm going to do it again. Second trace, intersection, enter, enter. But for my guess, I need to scroll all the way over here so that it finds this one. And once it says intersection, it should be flashing at the right spot you were looking for. All right, someone's going to have to help me. This would round to 2.71. 5.54. Did I hear you right? Thank you. Okay, so at what times was the rocket exactly 300 feet around, above the ground at those 2 times? All right, for some reason we should have written this in earlier, but we graphed y equals negative 16x squared plus 132x plus 60. my graph looked roughly like this. And the window I used, I remember it was 0 to 10. Was it 0 to 400 or like negative 10 to 400? Okay. I ask you for that information. I don't think I asked on this week's quiz, but I know on the final exam it asks, because if you write down for time negative 10 to 10, does that mean you understand the situation very well? We're going to practice this a lot before I grade on this, but if this situation is talking about time, your X should start at 0, right? And your window here should go high enough. Now, if you had more time or more height, that would be fine. All right. How much time do we have left? Okay. Let's do this number 4, and then we'll come back and do one more calculator one if we have time. This number 4 is an area and perimeter question. Anybody remember how you find if we have a rectangle, okay, and the perimeter is 86 and the area is 432. Any ideas? Usually use 2 variables here. If we call this X and Y and X and Y, what can you tell me about the perimeter? Does anybody remember what perimeter is? So we add up all the sides. So if I add, yes, I'd get 2x plus 2y is how much? For this question, it says 86. And then how do you get area? Yeah, length times width, or x times y, is 432. Now, unfortunately, we're not doing things with 2 variables, so we need to get rid of one of these variables. So we're going to do a little snazzy work with this guy. What can we do to all those numbers? 2x plus 2y equals 86. If we divide everything by 2, we get x plus y is 86. So I vote we keep x and get rid of y. So how would we write this? So y equals 86. Yeah, be 43. Thank you. Fix me. Yep. Everybody on the video is going, no, Hofbauer, no. Okay, we're going to subtract an x over there, so we get 43 minus x. Thanks. Now we're going to plug this back in up here for y. So it's going to say x times 43 minus x equals 432. Okay, I'm going to take us back to last week, and we're going to solve a quadratic. We're going to distribute 43x minus x squared equals 432. How do we solve a quadratic? We can factor, we can complete the square rooting. We can use quadratic formula, right? But first thing for any of those, well, I guess not completing square, but it has to equal what? 0. Now, would you guys be okay if I added the x squared over here? I like my x squared to be positive, and subtract my 43x over here. So mine is going to say 0 equals x squared minus 43x plus 432. If you moved it the other way, the signs would be the opposite, and it would still work. I just like it when x squared is positive. Now, most of us would probably have to resort to quadratic formula. This does factor. Can I give you a hint because you're tired on a Tuesday? This feels like a Monday. Try 16. I'm trying to remember. 432 divided by 16. 16 and 27. Would that make 43? They were both negative. How do I know they're both negative? To multiply to make a positive, I need two positives or two negatives, right? To add up to a negative in the middle, they got to both be negative. Now, I probably would have had to resort to quadratic formula because those are not nice numbers. All right. So we solve by setting it equal to 0, and we get 16 or what? 27. Now let me show you a little magic. If I put 16 in here, 43 minus 16 is 27. If I put 27 in there, 43 minus 27 is 16. So the length and width are either 16 by 27 or 27 by 16, okay? Dimensions are 16 by 27. Okay, how would you feel if I said, oh, I might have forgot to put that question on the quiz? I think the only application I gave you on the quiz is one of our throw-up problems where we get to use the calculator, okay? Want to try this one real fast? Can you type that in? How fast can you type that in? I'm not going to do it on the screen. I'm going to do it on mine here. Negative 4.9. The reason it's 4.9 and not 16 is because this question is in meters and not feet. Plus 229x plus 234. I don't know. How does our window of 400 help? Does it work or not hold out for this one? Ooh. Not even close. Okay, so 10 seconds, it isn't showing mine coming back down either. Is yours coming back down? Okay, so what should we try for time? Somebody pick an x value. 2,000 for x? For y? Okay. Did anybody try more time? How about 30 seconds? I don't know if that's going to work or not. 0 to 30. Can I see it come back down? Wow. Oh, this is a rocket into space, Hofbauer. All right. I don't know, 100? Still not coming back. Oh, yes, it came back down around 50-ish, I think. So if we did this 0 to like 80, and you said 2,000 worked for this one? Oh, 3,000 works? Okay, 0 to 80 for your x's. You can use less than 80 and it works. And 0 to 3,000 for the y's. Ooh, 3,000 just catches the top. 50 works good here. Okay. So 50 or above and 3,000 or above will work. And here we put in y equals negative 4.9 x squared plus 229x plus 234. Okay, what is the height when the rocket was launched? Anybody? 234 meters. How high above sea level does it reach its peak? What are we going to use to find the peak? The maximum. And which one is the distance above sea level? The x or the y at the maximum? Careful. X is, or T is time. Yep, we have time is X and Y is height. We want to know how high it was above sea level. So I got it the maximum 2909.56. Did anybody else get that? Assuming the rocket will splash down in the ocean, what time does splashdown occur? What are we looking for there? Yep, the 0. And it's somewhere out around 50 or 60 seconds. I got 47.7. Did anybody get that? No? Yes? And mine ended up looking like this. Ooh, well, not exactly like that. All right. So the practice tonight is worksheet 14. turn to the last page of your packet and circle numbers 1, 3, 6, 7, 8, and 10. 1, 3, 6, 7, 8, and 10. There are also a couple Delta Math from last week. Make sure you've got those caught up, okay? Because we're already at Tuesday and the quiz this week is Friday. We're going to cover one more section on domain and range and function notation tomorrow. Oh, there it is.